All right, so next up on our idea of kind of concepts here is that of partial pressures. So what we're imagining here, we've got a little container here, and let's say, we've got some gas flying around, doing whatever. But we've got different types of gas in here, right? We've got some of this orange gas, some of this purple gas, and then, maybe some of this blue gas as well, right? All of this stuff is just kind of flying around here. And remember that we said that the pressure comes from these collisions with the wall, right? There's a collision there, there's like a collision there, and then, there's a collision there, right? So all of these gases are exerting pressure on the container. So if we kind of want to think about what's the total pressure, P total, right? What's the total pressure of this? Well, it's just going to be a combination of all of these pressures, right? All of these gases individually are exerting a pressure, and so we can sum them together to get the total pressure. So for example, if, I was pushing a weight up at, a force of, 300 pounds per, I don't know, foot or something like that, and then you're doing the same thing combined, it would be 600 and whatnot. So we can say that the total pressure is the pressure of A, we'll call that gas A, the orange one, gas B, and gas C, and so on and so forth, depending on how many gases you have. So the mixture of gases, right? The total pressure is just going to be the sum of these pressures. And these individual pressures are called the partial pressures, or the partial pressure of the gas, right? So if one is pushing at 1 atmosphere and another one is pushing at 2 atmosphere, one has a partial pressure of 1, the other of 2, and the total pressure is 3. And remember, all of our gases are ideal, so they all kind of behave approximately the same. So that's what we see in this kind of picture. So if you took these individual containers of gases that are all exerting a pressure, and then you combine them all into one same-sized container, you would just sum the pressures, right? So this 1350 comes from the sum of all of these. And so basically that's this whole concept. It's pretty simple, but we're going to insert like an equation, and as soon as people see equations and symbols, they kind of start getting tripped up. But all you have to think about is that the total pressure is just the sum of its parts. So let's say if a gas is kind of, 1/4 of, or makes up 1/4 of a mixture, it has a partial pressure of 1/4 of the total pressure. Right, and so you can see these numbers are essentially kind of the same, right? If it makes up 1/10, then it has 1/10 of the total pressure. If it makes up, half of the gas, then it has half of the pressure. And so basically just a fancy way of saying that is that the pressure of A, the partial pressure of a gas, is equal to XA times the total pressure. Right, so this is total pressure. This right here would be the partial pressure of A. Right, and this right here is our kind of 1/10, 1/4, whatever. This is the mole fraction. So remember, when we're saying 1/10 of the mixture, 1/4 of the mixture, 1/5 of the mixture, we're talking about PV equals nRT. And so what we're talking about is moles. So we want to know the mole fraction of this. So XA, the mole fraction, if you think about a fraction, it's just how much of a thing do you have over the total amount of stuff. So it's NA. NA stands for the moles of A. I guess. Moles of A over the total moles, so N total. So overall, the concept is pretty simple. If my gas makes up 1/10 of the mixture, then its partial pressure is going to be 1/10 of the total. And when I'm talking about 1/10, 1/4, whatever, I'm talking about the mole fraction. So I'm talking about moles of whatever I'm talking about over the total moles. So if we combined had $10 and 5 of it was mine, then my money fraction would be kind of 0.5, right? I've got half of the money. So let's take a look at an example. So let's see, a gas mixture contains 2.83 moles of O2 and 8.41 moles of N2O. The pressure is 192 kilopascals. What are the partial pressures? Cool. So think about kind of what you're given, what you have here. Just right, kind of have. Well, we know we have 2.83 moles of O2. We know we have 8.41 moles of N2O. And we know that the pressure of these combined, so we're talking about here is P total, is equal to 192 kilopascals, right? And what we want is the partial pressures of each one of these. So let's do O2 over here. So if we're thinking about partial pressures, we remember that the total pressure is the sum of the partial pressures. So you can say like P total is equal to PA or PO2 plus PN2O. So we know that's true, and then we also know this equation up here, that the partial pressure of A is the total pressure times the mole fraction. So we know that the pressure of O2 is equal to the mole fraction of O2 times the total pressure. And so if we think about here kind of P total, we're given that number right there, so we can plug that in. PO2 is what we want to solve for, so we can't just solve that right away. And let's think about the mole fraction of O2. If we think about what that would be, well, the mole fraction is just how much of the thing that you're interested in you have over the total. So X of O2 could equal the moles of O2 over the total moles. And so this NO2, is that something that we were given? Yeah, that's something we were given. We can have that number exactly right there. Let's think about this N total value. Well, the total amount of moles is going to be the sum of all the moles. In this case, we only have two things, so it's just going to be O2 plus N2O, however many moles they have there, right? So if you take this number, the 2.83, add it to the 8.41, you'll get 11.24. And so then you can just plug that into there. Calling this green. Plug all of those numbers in, and then you can solve for PO2, and you should get 48.3. And then think about your units here. The mole fraction is moles over moles, so no units. And then the pressures in kilopascals. So this is going to be kilopascals. You want to go ahead and do N2O on your own. So pause the video, do it on your own. You should get 143.7 kilopascals. There's some cool applications of partial pressures. It has a big effect when you're mountain climbing, you know, how much oxygen you have up there, and when you're scuba diving as well. So you can read your book or, you know, try to internet some stuff to see some cool applications of partial pressure. So call it big mountain climbing. I guess hiking, mountain hiking, I don't know. And scuba diving. partial pressures help explain a lot of the negative effects of scuba diving, potential negative effects.